Good morning. My name is Gia Mangino. Welcome and thank you for joining us today for the webinar, Advanced Oracle Coherence Monitoring with RTView OCM 6.0. Today's speakers are Marie Hoke and Everett Williams. Everett is SL's Senior Technology Director, and Marie is SL's Director of Sales and has been heavily involved with coherence monitoring from the beginning. Throughout today's webinar, please feel free to submit your questions using the chat panel located at the right-hand side of your screen. We'll answer as many as possible at the end of the presentation. For example, if you'd like to give us a sample coherence problem, we would be happy to help troubleshoot or monitor. If you would like a larger display, please right-click on the WebEx screen and revise within that window. Now it is my pleasure to introduce Marie and Everett.
Gia, thank you. This is Marie Hoke. I'm going to do a brief agenda review first. We're going to talk a few moments about SL's Oracle Coherence Monitor, or OCM. We're introducing Release 6.0 this month. Then we're going to provide a list of 6 alerts in the OCM that we think you should consider for your cluster. 8 alerts we think you should consider for your cluster. We are not going to be covering the new features for the proxy client connections and the proxy nodes themselves. We are planning a separate webinar for that because we thought it would take too much time. And we want to do justice to that topic. Then we're going to do a deep dive into 4 of the alerts, 4 selected alerts that we think are very important, and we want to explain to you why, what you should do when you see them, how you can troubleshoot those issues, what they mean. Everett's going to give you an introduction to event management and the console and creating alerts in the RTView OCM. We're going to have questions, and we also like to ask for your feedback on some of our future webinar topics. Oops, wrong way. Okay, so we just released Oracle Coherence Monitor 6.0.0 this month. Back in 2007, we released OCM 1.0. So it's been 6 years now, quite a while, and Everett and I have been working on this monitor together since 2006, so that's more than 6 years. It's really been a great, enjoyable experience for us. We've learned a lot about coherence. It always keeps our interest because coherence has changed a lot in 6 years. The use cases that people have are changing and becoming more complicated. We are also working with a much larger range of customers than we did in the past. When coherence was newer in 2006, 2007, most of the people that we worked with were developers. Coherence was used in kind of rocket science applications, primarily trading applications at big investment banks. It was considered a part of an application, and as such was frequently monitored, deployed, installed, and the code was written by a developer, and we were working directly with developers. Frequently, operations had nothing to do with coherence. A lot has changed. Coherence has become much more mainstream. We work every day with operations groups to understand coherence, to respond to coherence issues, to talk about how they are assuring stability and predictability in their coherence platforms, but we also still work with developers and testers as well. So it's really opened up a whole range of audience for the monitor. So going right into the 8 alerts that we suggest or that you consider having in place in your cluster, one of the most important is departed node. Everett will be speaking about that shortly. We have other webinars where we talk about the importance of the bad communication cluster alert, which looks at communication issues across the cluster. We find almost anything that will slow a cluster down or cause any issues or hotspots or bottlenecks or anything in the cluster will tick this alert. So it's a good one to have in place, particularly in your development and test environments, so you can see things that may not be working perfectly as you scale your cluster. We've had many customers ask for the low available memory after garbage collection. That is monitoring the potential rise in heat after garbage collection. We have introduced it in this release 6.0, and Everett will talk about that along with some companion garbage collection alerts like the next one, which is the high GC duty cycle alert. That is the percentage of time a node spends doing garbage collection, and as that rises, usually you want to know about it. So we suggest that alert for any coherence cluster. Everett will be talking about store failures. If you have data persistence in your cluster, if you're doing right behind or right through, you will want to know about that alert. And Everett will talk about how to understand what happens in the things that can go wrong in data persistence and how that affects the stability, the performance, and memory consumption in your cluster and the related metrics you might want to understand in this webinar. High task backlog, that's primarily a developer-centric alert, but in your cluster, if you have entry processors, if you're doing invocations, if you're using aggregators, or if you have any rights to the database, then you will be using tasks. You may be seeing task backlogs. You'll want to assure that your thread pool and the way that you have configured these services provides scalability and concurrency in your cluster, and the high task backlog alert will help you understand this better, detect it, and potentially make some changes to your cluster for the better. We also have two new alerts in this OCM 6.0 release that we suggest that everyone configure and use. It's the high JMX processing time and the no JMX connection. Everett will talk about the high JMX processing time because it's important that you know how to configure that, and also that the high JMX processing time is an important alert not just to assure that the monitor is accurate, but also because when JMX processing slows down in a cluster, it's an indication that the cluster as a whole is slowing down. And if the cluster is slow, one of the first ways you may find out about it is when this alert triggers. Okay, so the departed node alert. How does a node depart, Everett, and why should people care about that?
As Mark Salco always said in the bottom of our slide, is someone's always got to die, which when nodes die, they get kicked out of the network. And it's frequently a suicide of the node because once a node either is not responsive or is not getting responses from the rest of the cluster, it will actually terminate itself and then attempt to rejoin the cluster. Now, this can happen in several reasons. One, there may actually be a connection issue. You might get a split brain due to, the node get kicked out of the cluster. It might not be getting network connectivity. So that would be one option. Node gets segmented and can't get communication, so it may get kicked out and die, leave the cluster. Other options are things like out-of-heap errors. So you run out of heap, terminates, the JVM terminates. You may restart it, but then it rejoins as a new node. So lots of different reasons can actually cause this. None of them are good, and so we will alert the customer about this happened. You'll frequently get, if it's a storage-enabled node, you may also get a endangered all caches, which is another alert that comes back and says, we're repartitioning the cluster, and while the cluster is repartitioning, you're at risk. Your data may be at risk. So during that time frame, you may also see that alert that comes with it. If it is caused by, say, a garbage collection issue where you may go into a long GC, you might get a long GC error on it. This thing lasted a long time. Or you might get a high duty cycle because when they go into, say, a 30-second GC, it will eventually hit the timeout. Responses of the node will get done. The node will get segmented from the cluster and eventually terminate. The corollary to this one, which Marie had up, which is the departed node percentage. This is a much more critical alert in that it is a certain percentage of the nodes have left the cluster over time, over the period. And it's normally caused by either a loss of a machine, a rack, or possibly a split brain. Right? So that is a much larger, if that happens, it's, buzz the night shift or get somebody out of bed because, machines and racks are being dropped and you may be losing service. So that's a considerable issue. Along the lines of, what do you do to troubleshoot that? A little depends on the reasoning. Garbage collection, and maybe just restart the node. It may be go out and reconfigure check the GC properties and make sure those are correct. If it's actually a machine, you might have a hardware problem. It's maybe a network card issue. You may need to get your network people involved. If you've got a bad communication cluster or node alert prior to the dropping, again, that might have caused it. So you might need to get your network people involved and evaluate there. So when you get this, the first question, the first question is, well, what node left, right? And where you'll see this in our product is in our stability metrics page. The nodes will be listed here, providing a location, a host name, and an IP. Now, location is actually configured by each one of the administrators to uniquely identify each node in the cluster. And the reason for this over the ID is transient. So most of you know that, when a node leaves the cluster or a JVM leaves the cluster, it will, as node ID 1, when it rejoins the cluster, it may join as node ID 50. But it's the same JVM, it has the same configuration, it had the same start script. So there's really nothing different about this node other than its time which it joined the cluster. So you want to be able to trend those across time, and you want to be able to say it left and then it came back. And you want to be able to track that, instance as long. And that's why you would create location and set it up. We'll also show you the IP address and port, and then the last time it was joined to the cluster within the last scene item. So we'll then be able to go out, find that machine, SSH into it, view the logs, and do whatever's necessary to either, bring the node back up or, reconfigure your machine. So that is the, departed node in a nutshell.
Thanks.
And
did you talk about the log files, Everett?
We talked a little bit about the log files. The log files will be out in the Coherence that you'll need to go look at to deal with. So.
Right. Okay. All right. So the next alert we're going to talk about is what's the memory after garbage collection?
So the OC post-garbage collection memory alert that we put in place has really been requested by almost everybody who owns a Coherence cluster. We originally started working in memory with knowing total heap and working with garbage collection sizes and how those work. But frequently the garbage collection, we'll see some nodes that have, very frequent garbage collections, and then tracking total heap use is actually a good idea. But when you have slowly garbage collecting, things garbage collect every hour, they garbage collect, every 30 minutes, those nodes may sit at 90%. And there isn't really a issue with capacity with those nodes because they're maybe waiting for one or two transactions to happen that push them over the edge and cause the garbage collection. And when that garbage collection happens, they may reset to 20% memory utilization. And you're really more concerned about the actual low point in the GC sawtooth versus the high points. The high points, if they're very slow and the peaks are very long, it's plateaued instead of a jagged peak, you're really looking at the bottom. And what this says is, look for the bottom point and tell me when it's an issue. And normally the kind of the rules of thumb that we've talked about with most of the people in the industry is that when that low garbage collection hits about 60 to 75%, you're going to have a problem because you're at 3/4 utilization of a particular node. And at that point, the node is getting to the point where it might get to a constant garbage collection, causing long GC pauses, causing high duty cycles, and therefore, you're going to, you have a chance that that node may get kicked out of the cluster to begin with. So out of the box, we set this one to 70% for warning and 80% for alarm, which is actually quite high, but you're going to want to validate that for your app. And you're probably going to want the duty cycle to be relatively short, because once that hits the bottom, this value isn't going to change a lot. It's only going to change during the garbage collections, which vary across the items. So those are the items that you can do.
Do you want to also mention why you want to have enough heat for, in case you have any data loss?
Yeah, the heat tracking and monitoring heat is important for two reasons. One, you don't want an out-of-memory exception on any individual node, because that will cause can cause a repartitioning of the data if it's a storage-enabled node. You can also have, poor responses to your users if it's a process node that's servicing user requests. But the corollary to that is as this number rises across the cluster, and if you get it to go across all the storage nodes at, say, 80%, you will get to the point where you can't lose a node. It'll try to fail over, it'll try to repartition the data, but if the spread of the nodes that leave or the machines that leave is larger than the available capacity, then you're at risk of a catastrophic failure, right? One node rolls over to the other node, rolls over to the other node, and eventually it starts you start losing nodes and losing machines, and eventually it crashes on you. You can set the quorum policy to prevent this, but we find that most people don't. They don't know what the number to set it to, and they're not really sure how it will best work for their apps. So when that feature isn't set and isn't really settable, you really need to manage the garbage collection, the memory used after garbage collection, to ensure your clusters stay up.
So how would you troubleshoot this in the cluster if you got this alert that you didn't have enough heap or that your heap was rising beyond where you wanted it to after garbage collection, Everett?
Well, there are two items on that, and you would start with the screen you're looking at here, Marie, which is the All Nodes History screen. And the way this is read is that the right-hand side of the screen has the current time at the bottom. The left-hand side has the duration. So at this point, we're looking at 20 minutes of data. Each column is a node, each row is a node, and each column is a sample. So you can actually see within the screen the light green to dark green to light green to dark green is really the sawtooth pattern within the heap utilization. And if you're in a situation where you get this alert, and you really should go to this screen and look and see if it is a consistent thing and that your entire grid is running hot, and it's been running hot for a long time, or if it is a single node. If it's a single node, it may be as simple as you might have a memory leak, or there might be an issue with that node, and you can either add a node and drop that node, and that could cause it to clear up. You could correct it with adding the capacity and removing it. Or if it's going across all the other nodes, you may need to be in a situation where you're at a capacity overload. You're getting more usage than you know what to do with, so you may need to throttle the requests coming into the system. Or you might need to be, if you have new capacity you can add on, and you have that kind of flexibility within your virtualization, you may need to add new capacity to absorb the peaks that you're receiving. So those would be the primary ways to deal with it.
And Everett, if you were a customer looking at this, or you were just looking at this graph here of what the storage nodes are doing and what the process nodes are doing, what conclusions would you make from this? Are certain nodes, do they, have less available memory than others? I mean, are there...
Yeah, the way this one is, if you look at it, we have, you'll see the kind of light green, dark green lines going across the screen. Those are the nodes that are obviously more active, and they're doing, similar things. So you can see frequently within the screen nodes that are doing the same thing tend to garbage collect in the same models. So if you see kind of one of these nodes is not like all the others, and it should be, then you might have a problem here as well. So we would look at that and say, oh, is this node doing the same thing as everything else? And if it should be, and it's not, you might want to go take a look at that node in the logs and see what's going on as well.
Okay, and is there any other place in the monitor that you would go to understand memory usage by the nodes, whether there was a problem?
Yeah, what we would do is you would be able to go from this screen down to our node summary screen, our single node summary screen. And from there, in this screen, you actually get to see what's going on in the node. And WebEx is hitting our screen. There we go. Now it looks much better. Here you can actually do a multivariate analysis on the node from both a memory perspective as well as a communication and CPU. And you also get to see, what is actually running on the nodes. You get to see the ability to change your graph over time as well as zoom in and zoom out on this. And then this will lead you down to our garbage collection and memory trends and the JVM memory trends and JVM GC trends. One more down. The GC trends, this is where you get to see garbage collection. You can do analysis of what we call the duty cycle and how that's working, as well as the duration of GCs and the movement of the available heat based on garbage collection before and post garbage collection across each one of the garbage collectors. So they're both you can do a full garbage collection analysis once you've spotted the possible issue, troubled node. And this is nice so you don't have to actually, log into JConsole, go over to the node, and pull up JConsole, look at it, spot the node, drill down to the node, do the multivariate analysis, come in here and look at the garbage collection. And it's a pretty quick way to go about troubleshooting an individual node.
Okay. Well, let's go on to our next alert, store failures. Everett, can you give us a little rundown of data persistence and coherence and why we should care about store failures?
So early on, one of the main usage patterns for coherence was database offloading. Basically, you would put the grid in front of your RDBMS that couldn't handle all the queries that you needed or access you needed. And, it provided, you had an ORM capability within the cache store to map your Java objects to tables. And you would do read writes from the database. And one of the ways we have added to the product is actually allowing you to do analysis of, well, how well is that integration really working for you? Are you, how many reads are you doing? Are your reads uniformly distributed across the nodes, or is, one node frequently missing and having to go out and grab data from the database? And how well are those performing? So are they fast or are they slow? And this one really was we're really concerned if it doesn't, are the updates to the database not working? Are you not able to update the database? So we again go back to our history heat map model, where we added these capabilities to actually do a full cluster examination and analysis across all of the caches and how well they're working with the database.
So Everett, what are these lines here? Sorry.
The lines in this one are caches.
Oh.
So each line is a cache, and each column is a data sample of that cache. So the dark green line is our most active cache in the cluster, while our light green lines are less active. And with this one, you're seeing log scale. And the reason for log scale is to be able to see trends or correlations between utilization when the magnitudes are not necessarily the same. So you may have a cache that has a very large object, and you may have another cache that has very small objects, and you do lots of littles and one big. So you might want to see that relationship in utilization as they peak and valley, and to do that you would see log scale. But if you want to see absolutes, you turn log scale off, and it kind of gets rid of the noise for you and shows you only the absolutes. And what we're seeing here allows you to do both of those types of analysis. So again, we have store failures now. Store failures we see as two major parts. One is the application, which is store failures are kind of expected, where you're doing updates and you may be doing optimistic locking, and you're expecting that if you're doing an update through the coherence and that object has already been modified by another application on the database, you might error out there and that's okay, and you expect it. Other times we have applications where you shouldn't have that problem. You're not updating, everything's going through coherence, and you should never get a failure. So when we come with one store failure out of the box, that if you get one failure, you get a warning. And we set the number at 10 for the alarm level. Now, those aren't going to be your numbers, but they're numbers we put in there. So if you do have a database, I recommend turning on the store failures to know when they're happening, and then setting your thresholds appropriately for your app to make best use of the alert.
So, Everett, one more question. Say you're an operations person and you may not know exactly how everything is configured. Where can you see if you have any writes to the write through or write behind if there's supposed to be writes to the database?
Yeah, the way you would go is you would drill down on that dark green line. I believe it will take you directly to the cache to the cache summary. And from here, you'll see the persistence box right there in the corner. This one doesn't have any persistence, but you would see right behind or right through would exist in that persistence column. And then you'll see some values that are out there. One is the write queue. So this is the things waiting to be written when you're doing right behind, as well as your failures and total writes. So it's a good way to actually go in and look and see what's doing it after you look at the high level at the top. So
yeah. And why would you care about the write queue?
the write queue is really just the list of things you're waiting to write. So it's sort of your risk factor. It's the things that are currently in the cache that differ from what is actually on, well, normally the RDBMS or whatever data storage you're using.
Okay, that's good. So, anything else you want to say about store failures and the alert itself?
I think we covered that one really well.
Okay. All right, so we'll move on to the high JMX processing time. Is this just,
This one is kind of what we put in. It was kind of, well, why do you care? And it came in two things. One, we were seeing a lot of our new customers weren't going in and tuning their monitor. They were taking the out-of-the-box settings for sample rates and sample frequencies and sample data, and they were kind of pushing it out there, and it wasn't working very well for them. And the reason is they were trying to sample the data every 10 seconds, and it actually took them 15 seconds to actually sample the data, so their samples wouldn't line up, and the data wasn't very helpful to them at that point. So we thought it was important to kind of give them an out-of-the-box alert that says, hey, you haven't tuned this, you need to go fix it. And that's helpful to our customers. But then it also added the second thing is after you've done that, well, if it changes, that's a problem. Something is going on, right? If it normally takes you 5 seconds to collect all your data, and it's now taking you, 15 seconds to collect all your data, obviously the cluster isn't working at its best. The management service isn't even running very well. You could be having an issue with your hardware, your network, your nodes. You could be having a massive storage increase. You could be having garbage collections across the cluster. So this alert is going to come out pretty quickly saying, hey, I can't collect data. And then it's going to come back with, as it collects the data, you'll frequently see things like garbage collection issues pop up. You may see nodes departing the cluster, and you had a repartitioning event. So this is going to come out as the primary one. And what it also does is if your data is not being collected with a high enough level of quality, you need to at least understand that. I've been in situations with Oracle people, and when you're looking at the data coming out, you may make incorrect assumptions if you don't understand the quality of the data. The data is still useful. You just need to understand, hey, it might be slow. It might not be coming back at the right rate. So the number is offset. And that's what's helpful in this one. So what you do if you get this alert, the first place you would go is you would go to the Administration Metrics Administration. And what this basically shows you is, and we're running very quickly because the total time is very slow here, is you'll see a trend chart down there at the bottom, and it's basically incredibly fast. And it's going to show you how long on average it's taking you to pull the data. And that number goes above the setting of sample frequency, you're going to get this error. So as this number goes up, it'll show you where the data is coming in. Then you'll also receive those other alerts. And when those alerts come in, you'll also be able to redirect you to the appropriate screen for the analysis, whether it be GC, whether it be memory problems, whether it's communication difficulty. You'll be able to then direct from that spot. But this one's going to pop up quickly. You'll see it. You'll know how long it's happening and go from there.
So, Eric, let me give you a more typical customer scenario that we see here, because it can often take a millisecond or more per MB to collect it. So if it's taking a customer, say, 3 seconds, or, because you can do multiples of that, say 3 seconds to collect the data, what's the minimum polling interval that they would probably want?
Normally the sample we're pulling in is the rate at which the frequency at which we sample the data. So when we go out and say, let me give you the data and let me go look at it and tell you what's going on. We normally recommend that the the sampling interval being no shorter than 2x the average, the time for collection.
And 3x is probably safer, right?
And 3x is even safer. So normally for a 3 second, you're looking at probably 10. 10 is what most folks do. Then they'll go 30 if it gets to for the larger clusters. And a lot of it depends on your collection rates. We're not going to talk about them. We have lots of different ways to collect data based on the usage patterns and the size of your cluster. So there's a lot of flexibility there that we can deal with. But in general, you want it to be a third to half the sample frequency of the collection time, and that's where you're really targeting.
Okay, so if I could summarize what I heard from you here, Everett, is that the JMX processing time alert tells you when you may need to reconfigure the monitor to assure that you have accurate data, or it tells you that the data that you are collecting might not be completely accurate because it's taking longer to collect the data. Also, it's telling you that if the management service is really slowing down, the other services in the cluster may be slowing down as well.
Exactly. And it's not really accuracy as much as the understanding what you're looking at. It's accurate data. It's just you need to understand what you're looking at.
Yeah. Okay. So I think we are now, I somehow missed a slide here. So we'll do this slide anyway. I was going to ask you to talk about, here it is, the event console, how you configure alerts, kind of the nuts and bolts of what's in the Coherence monitor and how people can use it better.
Excellent. Well, one thing we did with our 6.0 is we redid our alerting system. We had moved in, we realized we built lots of these solution packages for different customers and built lots of application monitoring tools. And with those tools, everybody was generating alerts. So, and it kind of grew over time. But then we decided we really need to be able to bring all these things together so that you could see all the alerts in one page. So it was kind of a critical, I have Coherence, I've got WebLogic, I've got database, I'm getting alerts out of each one of them, I've got custom systems. Let me get one vision of alerts. So we went through the legacy stuff that we had written and decided on a standard, and we now have the ability to integrate all our alerts to our enterprise monitor tool to actually get the data. And what you're seeing here is actually the new generation of alerting. And this is the alert detail page. There's the alert details. And what you're seeing is you see whether alerts are very similar. We added and changed the names a little bit, so if there's any custom integration, if you're an existing customer you've done to look for a particular alert. We added an OC for Oracle Coherence to the front of every alert name. So if you have that, you're going to want to know about it during the upgrade process and deal with it. We improved our alert indexing, which is effectively the alert context. Right, what cache, what name, and there's a lot better data in that field that allows you to go out and say, where did this alert come from and how do I go find it? So that's where you come from here. But then we also have acknowledgement, which is an existing item, as well as cleared alerts. We then came back and said, well, previously we would keep our alerts in memory, which is good, except we now wanted to be able to store them, restart them, restarting the servers. So now we persist all the alerts to a database so that you can actually go out and, when you restart your servers, you don't lose any of your alerting information within the OCM, which is a new feature of our items. So you can, acknowledge, you can set an owner, you can add comments, you can see details. So there's a lot better feature. We now have the owner filter at the top, which means you can assign an owner and then just filter it down to, Coherence or second-level support, and then you can go through and change it. So it allows you to provide a sort of a workflow or a listing capability within the tool if you so well need to. And that doesn't necessarily mean you're going to replace your listing tool. We still have the integration capability. You can still integrate with scripting. You can still integrate with Java. You can, whatever you need to do to get it to another tool if you have it, still have those there, but we wanted to provide you some capabilities here as well.
Great. And Everett, can you share how the current alerts work? I mean, how they self-clear?
Yeah, what is the self-clearing on the alert is we look at alert until it's valid. So if you hit an alert that says you're running out of memory, and we watch for 60 seconds. For 60 seconds, you were at 85% memory, and we fired the alert. But then we looked another 30 seconds later, and you were down at 20% for some reason. So the GC finally cleared, and it popped out. We're going to go back and say, well, it happened, but it's not a problem anymore, so you don't need to go worry about it. So during that, we will self-clear alerts that as the systems clear themselves. Now, we keep a record of it. You go back and look at your clear. You can go look at how they went through. But you don't have to worry about if an issue comes and goes, it doesn't need to show up in your work queue, is effectively how that helps you. So it's actually quite nice that way.
That's great.
So we also added, and Marie's going to come show up, is we also improved the administration of the alerts. So along with the persistence of the actual alerts themselves, the way we define the alerts changed. So some of them are very similar, warning level, alarm level. So if it's kind of bad, it's really bad. And how long does it need to be there, the duration? You know, how long does it have to be bad or really bad before you tell me are important. But then we added this really nice feature which allows us to override alerts. So by creating indexes, you can, on the alerts, you can now define lower granularity of thresholds and for warnings, alarms, and durations. And really one of the nice ones, and Marie's looking at it right here, is the override setting on departed node. And why this one was important is a lot of our customers said, you know, I don't really care if a processing node comes and goes. That's going to happen. I have lots of them. They come, they go, they leave. What I do care about is that I lost the storage node. That's important. If that happens, you know, get us out of bed because we're going to have a problem. So this allows us to go through and set it by per node, per cluster. So in a multi-cluster state, you can do it at a cluster level. But if you select per node here on IAM, it's going to show you the node list. Now, what it allows you to do is then select the connection and the location, which is defined, we talked about before, and whether you want to enable or disable it. And then once you've done that, you hit save and add, and it will actually put the new alert in. I don't think Marie has rights how she logged in to do this, but it allows you to then add the alert, and it allows you to say, okay, go through all your storage nodes, set those up as enabled departed node, and then you only get that alert. So that's a much finer granularity of alerts. And we've done this on most of our alerts. We probably can't go through them all today. But it's a good new feature for us. I think a lot of customers are going to be pretty happy with it. So they can trim their alerts down and make them more useful and less annoying.
All right. So you would set, for example, all thresholds on all nodes to be a certain number, but then this override column here would show you if you had any exceptions to that you would set, right? And then you
Correct.
see those. Right now we don't have any set up in here. Okay. Okay. And then also, you want to remind them that we have this too, Everett, because sometimes people...
Yes. Our alert disable button. If you're bringing your system down or you're doing fully restarts, disable your alerts. They're just going to fill up your queues and annoy you. So just disable them if you're doing it in maintenance or software upgrades.
Okay. I think we are at the end. So if you have any questions or if there's any specific kind of problem or condition you want us to talk about, how we would troubleshoot it, debug it, alert for it, or gain more understanding in the monitor, please volunteer. It makes these discussions more exciting. Also, if you have any comments on webinar, whether you'd like any of these 3 webinars in the next few weeks, let us know. We're going to talk about proxy clients, proxy connections, and the new features in 6.0 deep dive. I'm just trying to figure out which one to schedule next. We're going to have an OCM 6.0 upgrade webinar for our current customers, and we're going to show the centralized console for all Coherence clusters in Enterprise Monitor, what you can do at the next level up to get a more holistic view of your whole Coherence application, or maybe just a more holistic view of all of your Coherence clusters. Gia, do we have any questions?
Yeah, so thank you, Maureen Everett. I would just like to remind everyone that you can submit questions via the chat panel or the Q&A panel on the right-hand side of your screen. And I'd also like to point out that the slides from today's presentation, as well as a recording of the webinar, will be made available. We do have a few questions. This first question, this tool is low overhead when running in a production system.
So, Everett, do you want to comment on how people would estimate what the overhead is and potentially how they would minimize it?
Yeah, we normally target between 2 and 5% utilization of the overall system capacity for monitoring. That's kind of where we target, and it varies, of course, based on your requirements. And we do this through several ways. One, obviously your sampling period by extending it is a good way to go about it. We also have an item where we actually have our own custom collection model. So our JMX tables model allows us to reduce the overall load on the system by optimizing the data collection for our usage patterns instead of the current optimization, which is the base one for Coherence. So through those two items, you actually can check the utilization. And we actually have a new feature in the screen which will actually give you a good feel for that if you actually go, and we now have the packets sent and received added to the nodes history. So you can actually see the overall utilization in the system and how all the other nodes are using data, the network, versus the monitor itself. So again, we target for 2 to 5, and we can configure it appropriately to get it down into that range based on your total system usage.
And Everett, I'd like to make a comment on that too from our experience with customers. We think of large clusters as ones that have a lot of MBeans. And it's not necessarily what you would think of as a large cluster, because you might think of a large cluster as having a lot of machines. We think of it as having a lot of MBeans when we go to get a snapshot. So the more MBeans, kind of the more work is needed to be done to get the snapshot, potentially overhead. So if you have a lot of caches, if you have 2 caches, 10 caches, no big deal. But if you have 100 caches, 200 caches, that's where you will want to discuss that with us so we can minimize the overhead and maximize the real-timeness of the data and the ability to get a consistent snapshot across all of it. So if you have hundreds of MBeans, no problem. If you have tens of thousands of MBeans, that's our specialty, and we would encourage that you talk to us about that scenario so we can help you.
Okay, great. Thank you. Can you send emails for alert notifications?
Yes, we can. We come out of the box with a script, a shell script batch file implementation that will actually send you an email. But you can then modify that script to do with it whatever you want. So out of the box, yes. And then you can enhance it as necessary.
Great. Thank you, Everett. Is the performance data harvested from the Coherence MBeans, or do you have your own agent running in the Coherence nodes?
It's harvested from the Coherence MBeans. We have, if you go to our custom collection models, we do have a small install, a jar that you need to include in your class path, and a few settings in Coherence if you choose to go that way. But if your cluster is small enough and you don't need that kind of optimization, you basically can just point this thing at the management node for Coherence and it collects it for you.
I would like to add that Everett did several webinars last year on creating your own custom MBeans that can expose information about your cluster in Coherence, potentially even business information. I think there were a series of 3 of them, and he had some sample code. If you have your own MBeans or custom ones or ones that aren't part of our monitor, you can use our monitor to collect that information, to alert on it, to create displays showing what's happening. And we have 3 webinars on our website that will give you a how-to on how to do that.
Great, thank you. Can anyone set up the alerts, or do you need special permissions?
You need special permissions. It's just a standard, hierarchical, you have these rights, you don't have these rights, so we don't want everybody setting up alerts. We want people who know what who know what they need to set.
Can you send alerts to Tivoli or HP OpenView?
We allow for the interface, and we've had some people do it. We do not have an out-of-the-box version of those, but it is not difficult at all.
Okay. And can you tell me more about the bad communication alert?
The bad communication alerts, they come up in really two different sizes. Effectively, they are issues within TCMP. So when it says bad communication, Coherence nodes talk with what's called the Tengatal Cluster Management Protocol. And this is a UDP extension that basically guarantees packet delivery within the protocol. Now, the packets are still getting there. The only problem is that they're not being received on the first send. So you have two different versions of it. One is the publisher success rate, and the other is the receiver success rate. The publisher success rate is the node sending the data is having to resend data. The receiver success rate is I'm getting the data more than once. So they have a tendency to be, they correlate very, very strongly unless you are actually losing packets along the way. So if you're actually losing packets, you're going to have to send them more than once, but the receiver hasn't gotten them. Okay? So normally the troubleshooting in this model goes in several ways. One, you look to see if any NACs are coming out of the nodes, which we have available in our product, and you can see it through one of the tabular forms. And if you are actually getting NACs, which means I didn't get the data, then you're probably dropping packets. And at that point, the troubleshooting clause is you have to go out to normally your buffers, or it's a DC issue, right? I'm DCing and I'm not able to get all the data off the buffer, and therefore the buffer's overrunning and I'm losing packets. The other one is the buffer size is too small and I'm getting too much data in and I'm overrunning the buffer and it's not helping it. The third option is something's wrong with your network. That's normally a much worse situation to deal with, and you need to get your network people involved to deal with that. So the cluster will run as that number goes down. It doesn't necessarily stop running, but what you're doing is you're sending a lot of data over your network that may not actually be doing anything. So it's an efficiency, it's a capacity consumer, and you're consuming capacity and getting nothing for it. So we feel it's important to alert on it.
Thank you, Everett. Thank you, Everett. Does the product also allow editing the custom Beam properties like JConsole?
We do have an editing screen that allows you to both edit, to update items that are within Coherence that are editable. It also allows you to call the methods that are callable within Coherence, so reset, clear cache, insert cache. And these are secured behind within the hierarchy of rights within our product as well. So yes.
We do not have any further questions at this time. I would like to thank everyone again for joining us on today's webinar. If you're interested in a demo of OCM in your environment, please contact me directly or contact Marie at sl.com. And thank you again. Have a great day.
Thanks, Dia. Thanks, everyone.
Thank you very much, Dia.